In this video, we're going to look at something really interesting. Now, the interesting part is the relationship between x to the power n and something that we call n factorial. Okay? The relationship between x to the power n and n factorial. And before getting into the depth of this relationship, what you need to know about the derivatives is that you can continuously take derivatives for a continuously differentiable function, of course. So when we take f dash, okay, or say df by dx, if it's a function of x, this is the first order derivative. What is this? For any function fx, this is the first order derivative. Okay. Now, when we differentiate df by dx again with respect to x, when we differentiate df by dx again with respect to x, what do we get? We get d square f upon dx whole square, right? That's something that we call the second order derivative. It's the derivative of the derivative. It's called the second order derivative. It's the derivative of the derivative. And similarly, I can differentiate something to thrice also. So d by dx of, say, d square f by dx whole square. That will give me d cube f upon dx whole cube. Okay. So that's f triple dash, triple prime. Okay. And so on and so forth till n, if the function is n time differentiable till n. So we can just mark it as f n x, okay, instead of making n times prime, which is a difficult task. So we can just put it as f n x, which is nothing but d n f upon dxn. You can even quote it as, you don't need to all the time put whole square, whole cube. You can even put it as dx square. Okay, this can be put simply as dx square. This can be put simply as dx cube. Okay, so if my function is something that I call x to the power n, if the function is, say, x to the power n, okay, so a polynomial x to the power n is my function. If I differentiate it once, what do we get? We have derived it, right, previously, and for that you can refer to my previous lecture also. So d, now this capital D also denotes the same thing. There are many ways of writing differentials, f prime df by dx, or say capital D. That's also the same thing. That's a sign for derivative. It's only. Now, if I differentiate once, okay, so I get n x to the power n minus 1. Now, what becomes my polynomial? N is a constant outside, and my polynomial becomes x to the power n minus 1, right? So I differentiate again. In case I differentiate again, what do I get? I get n as it is. N was as it is. Now, when I differentiate x to the power n minus 1, I get n minus 1 x to the power n minus 1 minus 1. That makes it n minus 2. Correct? So, that's what I get. And within this differential, what do I have? I have a function instead of x to the power n minus 1. I have a new function which is x to the power n minus 2. So, I can differentiate again. So, in case I differentiate again, so d cube xn would be n minus 1 are the constants outside. And when you differentiate x to the power n minus 2, you get n minus 2 x to the power n minus 3. And so on and so forth. I can differentiate, say, to n minus 1 level. Okay, I can differentiate n minus 1 times. If I differentiate n minus 1 time, what will happen? If I differentiate n minus 1 time, what will happen? I will have n minus 1, n minus 2, and so on and so forth till what place? Till what place? Till n. Just mind you, what is happening here is that you are subtracting n minus 1. So what goes? N gets cancelled, 1 is something that remains, okay? And x to the power, only 1 will remain, as 1 remains here, because n minus 1, only 1 will remain, okay? So x to the power 1. And if I differentiate this another time, what will happen? X to the power 0 will remain. X to the power 0 will remain, because n, it will become n minus n, which equals to 1. X to the power 0 is 1. So what do I get? I get n into n minus 1 into n minus 2, so on and so forth, into 2 into 1. And this is nothing else but what we call in maths, something that we call n factorial. N factorial. This is the formula for n factorial. So what do we gain out of this video is essentially, in case you differentiate x to the power n number of times, okay, n number of times, okay, you get n factorial. This exclamatory mark for factorial.